we are done with atomic mass, we are done with molecular mass. Okay, now we are going to move to molecular mass, and this is very important. So those who are appearing for competitive exams like JEE or NEET, they should follow a particular method for solving empirical formula. Okay, so see what exactly formula is. Formula is a group of notation, a group of notation. Okay, whereas molecular formula defines number of atoms in a molecule, whereas empirical formula defines least number of atoms present. So these statements are somewhat confusing, but when you will solve a question, then you will get to know. First, I'm going to give you a layout of how to solve questions based on empirical formula. Okay, so let's start with this empirical formula. In first column, there would be elements. Next would be percentage. In third column, you are going to divide percentage by atomic masses. In fourth column, what you are going to do, the number which will you get from the third column, that is suppose you are getting a number A, then you are going to divide that number from the smallest number in the column. After that, you are going to get a number, that is suppose you got a number B. For example, the elements which are given are carbon, hydrogen and oxygen. Let us suppose their percentage are given, which is 40%, 60%, sorry, 30%, 60% and 10%. Now in third column, what you have to do? You have to divide percentage by their atomic masses. So 30 divided by 12, 60 divided by 1, 10 divided by 16. Okay. Now, after dividing, what you are going to do? You have to check what are the values of these division. So 30 divided by 12, it comes 2.5. 60 divided by 1 is 60 and 10 divided by 16 is 0.625. Okay, so out of these three, which is the smallest one? So 0.625 is the smallest one. So now what I'm going to do? I'm going to divide all these numbers by 0.625. So 0.625 divided by 0.625 divided by 0.625. Now in the last column, you will get certain values. 2.5 divided by 0.625 is 4. So you got B for carbon is 4. 60 divided by 0.625 is 96. And 0.625 divided by 0.625 is 1. All good? So your empirical formula would be C4H96O1. See, this formula is not correct because I just assumed the values. Okay, we'll do an exact question for this format. I just want you to write this format, how we are going to proceed. In first column, there is elements. In second column, percentage. Then what you have to do? You have to divide percentage by atomic mass, that is 30 by 12, 60 by 1, 10 by 16. And after that, what you are going to do? You have to find the smallest number out of which out of these three, and then you have to divide each number from the smallest number. So 2.5 divided by 0.625, 60 divided by 0.625, 0.625 divided by 0.625. Then you will get a number which will define the number of element in your empirical formula. So C4H96O. Now let's do a question with exact data so that your answer is correct. Okay. Can everyone see example 32 on the screen? Okay. So what is the simplest formula of the compound which has the following percentage composition? Carbon has 80%, hydrogen has 20%. If the molecular mass is 30, calculate molecular formula. See, first you have to calculate empirical formula. So let's calculate empirical formula. How you are going to calculate? See, in first column, elements are written. In second column, what is written? Their percentage. Then number of moles come to directly to this column. What do you have to do? You have to divide percentage by atomic mass. 6.66 and 20 divided by 1 is 20. Out of these two, 6.6 is the smallest. Therefore, we divided 6.66 divided by 6.66, that is 1. And 20 divided by 6.66 is 3. Therefore, what you got? Carbon number is 1 and hydrogen number is 3. So your empirical formula would be CH3. Is everyone following or not? People, I want you to drop message if you understood. Yeah, that is okay. Now, in question, you have been asked to calculate molecular formula. Okay, so let's proceed to molecular formula. See, there is a relation. Molecular mass is equals to N into empirical mass. Now, what is empirical mass? You got this empirical formula. Okay, so if you calculate mass from this formula, then it will be known as empirical mass. So 12 plus 3 into 1. This will give you empirical mass, which is 15. So N into 15. And you have been given molecular mass, that is 30. So N will be equals to 2. So if you multiply this N to your empirical formula, you will get the molecular formula. So 2. So now what you have to do? CH3 whole twice, that is C2H6. This is your molecular formula. All good? Now, let's get to second question. Somebody found the questions very simple. Now, can you see question number 23 and 24 and try yourself? I want you all to solve question number 23. Follow these steps. Everyone, please follow these steps. That will be easy for you. Drop your answer in chat box. Is it too difficult for you guys? Do I need to solve? Or I need to wait? See, you won't get this much of time in your competitive exams. Yeah, somebody found very easy the last question, so I just gave a question that need to be solved. Okay, so don't worry. If you won't get, I'll tell you. Okay, I'm going to solve this now. Or do I need to wait? Drop your message in the chat. Come on, guys. Okay. So, Vishwa got an ratio of 1.8, 0.9 and 2.8. Okay, Vishwa, atoms are not in fraction. Therefore, you can round it off. 1.8 You can write 1.8 2, 0.9 as 1 and 2.8 as 3. Okay, so your formula will be, yes, Krishna, you are absolutely right, Na2CO3.
Okay, ma'am. Ma'am, we have to change those things as whole number.
Yes, you have to, because atoms are not present in fractions. Okay, so it is
Okay,
always
ma'am.
in whole number.
Mm.
Okay,
Thank you, ma'am. Mm.
yeah. Rupam, you have written carbon hydrogen oxygen ratio as 2:1:3. Okay, have you solved the next question also? You just wait for others. We are going to do some more questions, right? Okay, I'll give you just a quick solution, then you can solve on your own. Okay, so first, elements. What are the elements? Sodium, carbon, and oxygen. Then percentage of sodium, 43.4, 11.3, 43.4, 11.3, and for oxygen is 45.3. Okay, 45.3. So in second column we wrote percentage. Now percentage should be divided by atomic mass. Atomic mass of sodium is 23. 11.3 divided by 12 for carbon, 45.3 divided by 16. Okay, so 43.4 divided by 23 is, tell me, 1.8. Then this is 0.9. Then oxygen,
2.8.
pardon me,
2.8.
2.8. Okay, 2.8. So smallest in these three are 0.9. So 1.8 divided by 0.9, 0.9 divided by 0.9, and 2.8 divided by 0.9. Okay, so 1.8 divided by 0.9 is 2. This is 1. And 2.8 divided by 0.9 is 3, approximately 3. Therefore, formula is Na2CO3. All good?